Thank you. Nice to meet you, everyone. Thank you for giving me the chance to share our study here. I'm Chaolong from Southeastern University, Nanjing, China. The title of our study is Affective Interaction in Domestic Service System, Emotion Evaluation and Regulation for the Older Adults. The main contents of my presentation today include the following 5 parts. First is the study background. As we know, as the populations around the world are rapidly aging, the demand for indoor care for older adults living alone constantly surges. Health emergencies, such as COVID-19, make the contradiction between the supply and demand of indoor service more prominent. Many resources need to be consumed to take care of these people, which creates a heavy burden on their family and society. So we are motivated to carry out our study and try to deal with these problems. Here we list some typical robotic systems and smart home systems. They were designed to help achieve active and healthy aging in place with functions covering daily living activity assistance, monitoring, communication, and so on. After reviewing many previous studies, we found that the main problem faced by aging in place include the physical care and mental care aspects. Physical care is the foundation, while mental care is a high pursuit. Since the needs of the former are always first met, meeting the needs of the latter one becomes the primary issue and should not be ignored. After considering the side effects of medication that further decrease the function and the quality of life, the current best practice recommends effective interventions as the first line of treatment. However, how to evaluate their physical and mental state and find a suitable time to intervene is one of the fundamental issues. Here are some common methods of emotion recognition: facial expression recognition, speech-based emotion analysis, and some other approaches based on gesture, biometric signals, gaze pattern, and so on. Actually, heterogeneous human behavior can be used as a basis for effective evaluation. For facial expression recognition, it is one of the common methods of emotion analysis, but it is very difficult to reliably guarantee accurate identification of the older adult's emotions using this method alone. As we can see on the screen, low expressities, age-related changes in the face, may low decoding accuracy for older faces. In addition, age-related stereos and changes in the face may be biased towards specific emotions, such as sadness attributed to older faces. Here is the architecture. On the left are the application scenarios we expect to achieve. We build a domestic service and effective interaction robot shown on the right, and design a multimodal effective interaction mechanism, which not only assists user decision-making and user intention recognition in daily life, but also guides users to carry out positive emotional impressions. Here's the details. The system consists of 2 models. One is the user state evaluation, another is the effective interaction. Our goal is to create a system that supports independent daily life while caring for older adults' physical and mental health. Effective interaction interventions is activated based on the emotion evaluation to improve their emotional states. Here is the method, the details as the picture shows. First, user study needs to be conducted to to connect the user data. Subsequently, data features are extracted to establish a user behavior model. Then the calculation of the model deviation based on the user real-time usage data is processed. We use the facial expression recognition to determine whether the intervention of the affective interaction is needed. If the criteria are reached, the multimodal affective interaction will be used to recommend suitable activities and guide the user to express their requirements. After user selection, user's emotional expression and persistence during the activity are collected and analyzed during the interaction. Here are some of the things and the manuals we designed, including service system functions and affective interaction interventions functions. As we mentioned about to enhance their mental health, one possible way is to engage them in activities they enjoy. Therefore, a set of proactive intervention scenarios tailored to their preference is added to the implementation of basic service functions in our automatic service system developed for older adults. Yeah, here is the experiment scenes and the expressions of different emotions we used on the service robots. After completing the system function test, we invite an older adult to carry out the system physical test. As shown on the screen, the emotion changes based on facial expression recognition near the affective interaction. The results of user behavior model deviation calculation and the facial expression recognition triggered the intervention of the affective interaction. It can be seen that older adults show a high promotion of nature emotion, while the rest was negative emotion before intervention. However, after the intervention, nature and the negative intervention decreased while positive emotions increased significantly. In the future, here the works we will conduct. We will study different user behavior model establishment methods and improve the accuracy of the user state evaluation. Moreover, more user studies need to be conducted to enhance nature and acceptable affective interaction and improve their user experience. Thank you.
Right. Thank you, Chaolong. We have time for a question. Any questions from the audience? If not, or when people are from the chart of emotion percentage by time, could you clarify from what kind of measurement did you get this data from? It's a question in the chat. Also, from Kazuki, have you actually tried the age users? Are there any feedback from them?
Yeah. Thank you for your question. At the moment, as I said before, the work is a pre-study state and there is still a lot of room for improvements. The feedback we get, actually, the activity needs the subject to choose it is everyone has behavioral habits, and our user behavior model is to model such habits and evaluate behaviors that deviate different from the user's behavioral habits, because such habits are subject to change and model building will not be very accurate. Therefore, we hope to simulate users' emotional impressions and evaluate their emotion states through multimodal communication. After the affective intervention is triggered, we will start affective interaction. So the multimodal interaction is proceeding. The activities decided to beginning will be chosen by the subject in personal. Yeah.
Okay. And for the question about the chart of emotion percentage by time, for like, what is the type of measurement did you get the data from?
We have carried out a user study for about a week, and some questionnaires we conducted to we designed to collect the user data to build the behavior model. Yeah.
Okay. All right. So it's kind of a self-reporting on these questionnaires.
Yeah.
Okay. All right.